Imagine a computer so powerful it could solve problems in seconds, and that would take the world's fastest supercomputer billions of years. Sounds like sci-fi, right? But it's not. This is a quantum computing, and the race to harness its potential to happen now. What if I told you the fate of the industry, medicine, and even nation could depend on who wins this quantum supremacy race? Stay with me as we unravel the quantum's world-scaling journey from its humble beginning to the jaw-dropping breakthroughs today. It all started with a peculiar question in the early 20th century. What if the rules that govern the atom and particle could power our machines? The Albert Einstein and Niels Bohr laid the groundwork with their debates on quantum mechanics. Fast forward to 1980. The IBM's Richard Feynman proposed a daring idea, which the computer that stimulate quantum systems using the quantum rules themselves. Think of classical computers as the skilled librarian who solved the book one at a time. Now imagine a quantum computer as an entire library staff working simultaneously, each solving different parts of the problem in parallel. Sounds beautiful, right? Well, it's about to get even cooler. The big leap comes at the end of 2024 when the Google's William processor achieved a quantum supremacy. It can perform a task just 5 minutes with the 105 qubits, something that would take the world's first supercomputer 10 septillion years, which is about 10 followed by 25 zeros. But there's a catch. Increase the qubit can also increase the error. Somehow, they managed to solve the error with the help of quantum error correction. Sounds simple, but here's how it works. In a classical computer, the errors are corrected by copying data easily, right? But in quantum computer, you can't copy qubits because of no cloning theory in quantum. Instead, we use the logical qubits. They are encoded across multiple physical qubits. So even if the error like bit flips, phase flips occur, the system can detect them and correct them using something called synchrone measurement, a small trick where the auxiliary qubits interfere without distributing the quantum states. And this breakthrough is the key to making the quantum computer more reliable, scalable for the future. Already, the IBM has built their largest computer, yet Osprey with the 433 qubits. And recently, the China stunned the world with their 545 qubits quantum computer, twice as powerful as the IBM's record holder Osprey. To put it in perspective, solving one of the problems classically would require a supercomputer size Earth itself. Yes, Earth. So how do they actually work? The quantum computers, at their head, called the qubits, the quantum bits that exist not just as zeros or one, but both at the same time, thanks to the principle called superposition. Even more fascinating is the entanglement. When the qubits are linked so closely, the state of one instantly affects the other even miles apart. Think of it like the twins who somehow know what the other is thinking. And this is a simple example. While the classical computer searches for right key by trying every log one by one, the quantum computer tries all keys simultaneously, which the efficiency is redefined. But why does that matter to you? The quantum computer can revolutionize the real-world applications, like optimizing the supply chains, developing the life-saving drugs. For example, finally, the Russia found the vaccine for cancer. But it's quite a long way. Even if we are achieving the quantum supremacy, we can find the vaccine for many diseases within a shorter time period than by doing classical computers. So that is how helps in medicine. And even creating hack-proof encryption. Or consider your online banking. The quantum encryption could make hacking impossible. If someone trying to encrypt a quantum encrypted key, the laws of quantum physics like the observer effect will alter the quantum state. Then this alerts the sender and receiver immediately. However, this isn't without its own challenges. The quantum computers are fragile. The qubit loses their state with the slightest vibration or temperature change. This machine can also require near absolute zero cooling, and that could cost millions to operate. Or like playing a vinyl during an earthquake, which is we can't even imagine. The question remains, can we scale this technology before the clocks run out? Even if, come on your thoughts here. The race to dominance of the quantum computing is fierce. The nations are pouring millions into this technology and recognizing its power to reshape industry and influence the geopolitics. The US leads with the firms like the Google, IBM and Ringtech, offering some of them with their own cloud services and even somehow their own quantum computer. But China is a catch up fast, aiming to take the leading supremacy of the quantum. And now India is making significant strides. The Center for Development of Advanced Computing, which is the CDAC, is building a quantum computing reference facility in Bangalore, which is set to be go live in next 3 years. The National Quantum Mission, approved in 2023, aimed to develop the quantum computer and research hub across country. The quantum computers are no longer just machines. They are the tools that could redefine the humanity is capable of. From curing diseases to solving the climate change and even unlocking mysteries of universe, their potential is limitless. But as we think with any powerful tools, their future depends on how wisely we use them. And the question is, are we ready for this quantum leap? If this blows your mind, then share this video and let others dive into the quantum world. And remember, subscribe for more deep dive into tech shaping our future. And that's it, friends. See you in the future.